Okay. Most of the time it's a 1 amp pulse, and then occasionally it'll do a 2 amp pulse. The charged battery circuit voltage is jumping all over the place. When I stop rotating, it's about 2.7, but there's really no stored energy in the battery. It's just a voltage reading. If I hook a load up across the battery, it immediately discharges and drops down to about 6 volts. So, because it was so discharged when we started the experiment, it'll take quite a while for it to store any energy at all at the battery, if it can still do that, because of its age and mistreatment. But we went to a one switch configuration, and because the other, after looking at the circuit and understanding how it was operating and the way the PMA was performing under load, the 2-switch configuration just didn't make any sense. Excuse me. We tried adding a diode between, let's see here, between the, so this is the circuit at this point. It's just one switch, and then, let's see here, get that straightened out. We tried a diode at the, at the input to the load, and it made between the dump capacitor and the load, and it doesn't make any difference. So there's no spikes going back into the system. And when I was let's see here, if we position the contact switch so that it's out, give it a vigorous turn, we get about 100 volts on the cap bank, and then discharge. So but I'm trying to determine where the load's coming from. Obviously there's no load when it hits the discharge, but I think it all goes back to the original problem, which was the I2R loss at the stator. So we'll have to when there's a voltage on the cap bank, it's extremely easy to turn, because there's no or very little current going through the circuit to charge the cap once it reaches the the high end of its voltage storage capacity. And it looks like at some point we definitely will. This is not a solution for to eliminate the DC to DC step down converter. Obviously that's happening much faster. The discharge and charge cycles are happening much faster, and so I think my circuit was set up to operate at around 20 kilohertz. So that's a lot faster than this is. But we'll make modifications and report results when available. Thanks for watching. Enjoy the day. Cheers. Okay, so the extreme load I was feeling during the rotation of the manual operation was coming from the contact switch. Wasn't triggering on some of the cams or cogs. Not sure what to call that. But when we fix the problem, it's much easier to operate. And I'm going to say about a quarter or 3/4 of an amp. Obviously, if you rotate the PMA faster, smell ozone or some sort of something happened. I wonder if I blew up my caps. They're still cold. And something's not charging the cap bank. So something happened where the circuit's not being completed. Oh. Not sure what happened. Anyways, the cap bank's no longer charging, so we'll investigate and report results when available. So, yeah, there's definite problems. It's not a quick fix, silver bullet situation, but it's pointing us in the right direction, which is what we already established. Using a DC to DC buck converter is going to produce best results. So, thanks for watching. Enjoy the day.